Okay, now we're going to look at solving rational inequalities. The ones we just finished were polynomial. These are rational, so actually just a couple of little adjustments. First of all, step one, bring all terms to the left, obtaining 0 on the other side. So you still want 0 on one side by itself, but then the other side needs to be just a single quotient, just a single fraction. Now, to find your boundary points, as step 2 says, this is a little bit different. You set your numerator equal 0 and your denominator equal to 0 in order to get what they call boundary points. Now, once you get your boundary points, actually the rest of it is exactly the same as it was before. So that's just why I said steps 3 through 5 stay the same. Okay, so the first one that we're going to look at, this one's actually set up exactly how it needs to be set up. We do have 0 on one side, and this side is just the single fraction. Okay. All right, so you don't have to worry about step 1. So step 2 is to set numerator and denominator equal to 0. So I take my numerator and my denominator. Okay, now when you solve each one of these, this first one we're going to get negative 5/3. And with this one we're going to get x equal 3. So these are my boundary points. Okay, so we're going to put the boundary points on the number line just as we did earlier. Okay, now my test numbers, so I need to pick a value that would be less than negative 5/3. Of course, if you need to get a decimal approximation for that so you'll know what you're dealing with, you can. But negative 2 would work. And then I could use 0, and then I could use positive 4. Now I've got to substitute each one of those, remember, back into the original function for x, just to see if we get a positive or a negative result. So if I substitute in the negative 2, then I'm going to have a negative result when I substitute in negative 2. Now if I substitute in 0, then I'll have a positive result. And then if I substitute in 4, I'll have a negative result. Okay, so now look at your inequality. We have greater than or equal to 0. Now, just like a while ago, if we ended up with something that was greater than, that told us to go to our section that was positive. Now, what you've got to be careful about, though, with the ones that are rational, as long as this doesn't have the line underneath it, it's just strictly greater than 0, you're going to use parentheses all the way through. But when you have the line underneath your inequality, actually you're going to use some brackets and some parentheses. Because, like, for instance, the 3, it came from my denominator. But if I were to substitute 3 in, that causes my denominator to equal 0. And as you've been told numerous times, you cannot divide by 0. So even though this has the line underneath it, this can't be included because it's from your denominator. The only time that a fraction is going to be equal to 0 is when the numerator equals 0. So that means you can include the negative 5/3, but you cannot include the positive 3. So you would put a bracket, negative 5/3, to the positive 3, but yet you can't include the positive 3. So just remember, never include any value that comes from your denominator. Okay, next example. Now the difference that we have with this example is it's not set up the way I need it to be set up. If you remember, the note that I had you to write down a while ago says that you do need to have 0 on one side, and then you need to have a single quotient on the other side. Well, getting 0 is not a big deal here because all you'd have to do is subtract 1. But in fixing that problem, you've created another problem because this side isn't just a single fraction. You've got 2 individual terms. So what you're going to have to do is get a common denominator. Of Of course, remember your 1 is understood to be over 1, so actually x minus 3 needs to be your common denominator. Okay, so you bring this numerator down as it is because it's already over the denominator that you need. But if you're going to have to multiply this denominator by x minus 3, you have to multiply the top times x minus 3. Which, as far as multiplying times 1, it's not going to change, but you do have subtraction there, so we will end up having to distribute the minus sign. And then I can combine the 1 and the 3. Okay, so see, now this is the form that we're wanting. We have a single fraction, single quotient on one side, 0 on the other. So from here is where I get my boundary points. So we're going to set our numerator equal to 0 and set our denominator equal to 0. So I get x equal 4 and x equal negative 3. Okay, do your number line. And then we need to pick a number, test value in each of these sections. So I'll go with negative 4, 0, and 5. Now, in plugging these in, the other ones I kept going back to the original, but the original already had 0 on one side. What you need to do here is go back to this step where you have it in the form it needs to be in. So do your testing for this particular problem at this step and not back here at the original. Alright, so if we substitute in negative 4, then I will end up with a negative. If I substitute in, let's see, is that right, negative 4? Yes. Then if I substitute in 0, I'm going to get a negative. And then if I substitute in a 5, I'm going to get a negative. Oh, I see where I messed up. I think so. That doesn't look right. I'm sorry, this was supposed to be a positive 3 right here. Okay, so we can fix this. This is positive 3. So actually I could still use my negative 4 right here, because that still is less. I do need to change this though. Let me just make this 3.5. So if I substitute in 3.5, yes, that's going to be positive. And then that's fine. So, okay. I did mess up there, but that was easy to fix. Okay. Now, when you're picking your section, you still go back to this step right here, where you have it in the form that you want it to be in. So less than 0 will tell me to go to my negative sections. Now, a while ago when I was stressing to you about making sure you don't ever include the value that comes from your denominator, in this case, that's really not anything you have to worry about because this doesn't even have the line underneath the inequality anyway, which is going to mean use parentheses all the way through with your answer. So we'll have negative infinity to positive 3, and then from 4 to positive infinity. So there's your answer for that. Okay, one more rational expression. Mainly just doing this so you can see getting a common denominator one more time. Okay, so we do need to get 0 on one side. Okay, but like I said a while ago, that creates a problem here because now we need to have a common denominator, which would need to be the 2x minus 1. Alright, so you can transfer this numerator down just as it is. But if I need to multiply this denominator by 2x minus 1, then I have to multiply the numerator by 2x minus 1. Okay, so distribute your negative 3. and then combine like terms. Okay, so your x minus 6x gives me the negative 5x, and of course 4 plus 3 gives me the 7. All right, so set each one of these equal to 0. Okay, so here, then I will have 7/5 and a positive 1/2. On your number line, your smaller value will be the 1/2, and your larger value will be the 7/2. Okay, and then we need to pick our test numbers. So I'm going to use 0. I can use positive 1, and then I can use positive 2. All right, substituting those, remember, back here. Down here is where you need to do your substitution. All right, so if I plug in 0, then I'm going to get a negative. If I substitute in positive 1, then that's going to give me a positive. And then if I substitute in 2, then that's going to give me a negative. Okay, this time, look at your inequality. We have less than or equal to 0. So the less than tells me to go to the negative section. Now, this time, since I have the line underneath the inequality, typically you would think brackets, but remember, do not include the value that comes from your denominator, which is the 1/2. So when I get ready to use my 1/2, when I write my interval notation, I've got to remember to keep a parentheses with it. So this would be negative infinity to 1/2. But now the 7/2 comes from the numerator, which is okay to have 0 in your numerator. So you will put a bracket on your 7/2, and then that goes to positive infinity. So there's your answer for that one.